Solar retinopathy has no warning. Your eyes feel nothing as the sun's radiation silently destroys the photoreceptor cells lining your retina. By the time your brain registers the damage, it is permanent. There is no surgery to reverse it. There is no medication to restore it. On August 12, 2026, a total solar eclipse will cross parts of North America and the North Atlantic. Millions will look up. Some will look without protection. Many of those people will never see with full clarity again. This is not a hypothetical risk. It is a documented, recurring medical event that happens after every major eclipse. What makes solar eclipse blindness uniquely devastating is that it operates in complete silence. No pain, no flash, no immediate signal that anything has gone wrong. The damage is measured in days later, when you wake and the center of your vision is simply gone.
The sun produces approximately 3.8 times 10 to the 26th watts of energy every second. Standing on Earth's surface at noon, roughly 1,361 watts of solar radiation strike every square meter of your skin. Your retina is approximately 0.0003 square meters. That is enough concentrated energy focused through your cornea and lens to raise the temperature of retinal tissue by 4 degrees Celsius in under 100 seconds of unprotected viewing. For context, that is the same thermal change that cooks a protein. Your visual cells are proteins. During an eclipse, most of the sun's disk is blocked, but the corona and even a sliver of exposed solar surface still deliver full-spectrum ultraviolet and infrared radiation. Your pupils, freed by the reduced ambient light, dilate. They open wider than they ever would under normal sunlight. The result is a larger aperture receiving the same lethal wavelengths.
The human retina contains 2 types of photoreceptors, roughly 120 million rods and 6 to 7 million cones. The cones are concentrated in a 1.5 millimeter region called the fovea centralis. This is where your sharpest, highest resolution vision originates. Solar radiation focused through the eye's lens converges precisely on this region. Ultraviolet wavelengths below 400 nanometers and infrared wavelengths above 750 nanometers are not filtered by the cornea. They reach the fovea and trigger a photochemical reaction that breaks down cone cell membranes. The damage is not caused by heat alone. It is a chemical cascade initiated by photon absorption that produces free radicals, which destroy surrounding cell structures. Destroyed cone cells are not replaced. The human retina has no capacity for photoreceptor regeneration. Where cones die, a scotoma forms, a permanent blind spot exactly where your central vision used to be. Patients describe it as a gray or black oval floating at the center of everything they see.
Here is what most people do not understand about eclipse viewing. The danger is not greatest at totality. It is greatest in the minutes before and after totality, when the sky dims enough to feel safe, but the sun's radiation output remains unchanged. Human pupils dilate in response to reduced ambient light. In normal bright sunlight, your pupil contracts to approximately 2 to 3 millimeters. In the pre-eclipse dimming, it can expand to 7 or 8 millimeters. That is a 3-fold increase in aperture, meaning roughly 9 times more radiation reaches your retina per second. The 1970 solar eclipse in the United States produced 145 documented cases of solar retinopathy. The 2017 American eclipse generated at least 100 confirmed cases, despite unprecedented public warnings. In the 2024 eclipse, optometrists across the eclipse path reported a measurable surge in retinopathy cases within 48 hours of the event. The trap is that the sky does the same thing sunset does, and your brain tells you it is safe to look.
Totality is the only moment during a solar eclipse when direct viewing is safe without certified filters.
The window lasts between roughly 10 seconds and 7 minutes, depending on location and eclipse geometry. For the August 2026 eclipse, maximum totality duration along the central path is approximately 2 minutes and 18 seconds. Here is the counterintuitive fact that injures people every eclipse cycle. The moment you sense the sun beginning to reemerge, the moment your instinct says the safe period is ending, your retina is already receiving concentrated solar radiation again. The problem is the human reaction time. The photochemical cascade that initiates cell destruction begins in milliseconds. Your decision to look away takes between 150 and 200 milliseconds. In that gap, damage is initiated. Experienced eclipse watchers use this rule. Remove your glasses 30 seconds before totality ends, not the moment it ends. The margin for error is measured in fractions of a second, and the consequence is permanent.
Consider what your eye's lens actually is. It is a biological focusing system designed to concentrate incoming light onto the smallest possible area for maximum resolution. It performs this function whether or not the light source is safe. Point a magnifying glass at dry paper under the sun. At the correct focal distance, the paper ignites. Your cornea and lens perform an identical optical function on your retina. The magnification factor of a healthy human eye is approximately 100,000 times. A source that delivers 1,361 watts per square meter to your skin delivers a focused equivalent exceeding 100 million watts per square meter to your fovea. Sunscreen protects your skin from the same radiation source. There is no equivalent biological protection inside your eye. Your eyelid blocks light, but not the heat your lens has already begun concentrating. Closing your eyes after the damage begins does not stop the photochemical reaction already triggered in the cells. The process continues.
What no one is talking about ahead of the August eclipse is a finding published in the past 2 years confirming that solar retinopathy is far more common than emergency records suggest. Most cases are subclinical, meaning the patient never notices a discrete blind spot, but loses measurable contrast sensitivity and fine detail resolution permanently. Researchers using high-resolution adaptive optics imaging can now resolve individual photoreceptor cells in living patients. What they found in individuals who viewed previous eclipses without adequate protection was consistent with a pattern, a mosaic of missing or non-functioning cone cells in the foveal region, producing degraded vision that the patient adapted to without realizing peak visual function was gone. Scientists now believe the true rate of eclipse-related retinal-related damage is 3 to 5 times higher than hospital case counts indicate. For every person who seeks emergency care after an eclipse, 3 to 5 others sustained injury they never diagnosed.
Here is what changes everything you just heard. ISO-certified eclipse glasses, the only type officially recommended by the American Astronomical Society, filter out 99.997% of incoming solar radiation.
They reduce sunlight to a safe level for direct viewing during partial phases. Yet in laboratory analysis conducted after recent eclipses, researchers found that a measurable percentage of eclipse glasses sold at retail in the weeks before major eclipse events failed to meet ISO 12312-2 certification standards. Some transmit ultraviolet radiation at levels that can initiate photochemical damage in under 30 seconds of continuous viewing. The glasses look identical to certified versions. The packaging uses the same certification language. The difference is undetectable to the human eye. The only way to verify a pair is legitimate is to source it from a vetted supplier listed by the American Astronomical Society, or to test it with specialized equipment that most individuals do not own. You cannot see the danger. You cannot feel the danger. And the glasses themselves may not be what they claim.
Solar eclipses are one of the rarest and most precisely predictable spectacles the cosmos offers our species. The geometry that produces totality, the moon's apparent diameter matching the sun's apparent diameter to within a fraction of a percent, is a coincidence of distance and size that will not persist indefinitely.
The moon drifts away from Earth at approximately 3.8 centimeters per year. In roughly 600 million years, its apparent diameter will no longer be sufficient to fully cover the solar disk. Total solar eclipses will cease to exist on this planet. Every human being alive today exists in a geological window, a narrow band of cosmic time during which this alignment is still possible. Yet the event that is rare enough to draw millions into fields and stadiums also concentrates the sun's most damaging radiation into the moment humans are most likely to stare directly at it. We evolved to track the sky. We did not evolve to safely observe the sun.
We have mapped the surface of Mars to a resolution of 25 centimeters per pixel from 225 million kilometers away. We have photographed a black hole 55 million light-years distant. We have resolved individual atoms with electron microscopes. We possess visual instruments of almost incomprehensible precision. Yet a person standing in a field in Ohio during a 4-minute window can permanently destroy the biological sensor responsible for all of that perception by simply looking up at the wrong moment without the correct piece of plastic over their face. The entire edifice of human scientific observation, from Galileo's refraction telescope to the James Webb Space Telescope, rests on the biological capacity of the human retina. The same star that drives all photosynthesis on Earth, enables all life, and ultimately generated the nuclear energy of every civilization that ever existed, can permanently disable our primary observing organ in less time than it takes to read one sentence of this script. Here is the question this video cannot answer. The Sun is a middle-aged, ordinary G-type star. There are approximately 400 billion stars in the Milky Way alone. If even a fraction of those stars host planets at the right orbital distance, and if even a fraction of those planets developed life with light-sensitive biology, then across the universe there may be an uncountable number of organisms that evolved under a star. And somewhere among all of them, some may have evolved eyes precise enough to appreciate the geometry of a celestial alignment, but fragile enough to be destroyed by the source that made those eyes possible in the first place. Is this an irony unique to Earth? Or is it a universal feature of visual life? That the very object your eyes evolved to process is simultaneously the object most capable of ending your ability to see? We do not know. We cannot know. And the August eclipse will come regardless of whether we have answered it.
The sun will cross the path of the moon on August 12, 2026, exactly as orbital mechanics predicted centuries ago. Whether you see it clearly, or whether you see anything at all afterward, depends on a few grams of certified plastic and the knowledge you carry into that field or rooftop or stadium. If this made you think differently about the star at the center of our solar system, the video we made on why the sun is closer to death than most people realize will take everything you just heard and scale it by a factor that will stop you cold. If you want to keep receiving this kind of content, subscribing takes 2 seconds, and it genuinely determines whether this channel can keep making it. Every subscription is one more person who will know what they are looking at when August arrives.